Finally, we're going to put it all together now. So we're going to solve each right triangle. And when I say solve, I want all the missing angles and all the missing side lengths. We will round our side lengths to the nearest tenth, and then angle measures are going to be to the nearest degree. And I'm just going to focus on one of these, 5A. You can use any technique that you want. You can use trig, you can use the Pythagorean theorem. If it's a special right triangle, you can use your special right triangles. Whatever you want to use, as long as it works and fits the scenario. So in this case, we need to find our side length FH. We need to find the measure of angle F, and we need to find the measure of angle G. Those are the three things that we're missing. I'm going to start with our side length FH, since I only need to find one side length. And since I only need to find one side length, I should be able to use the Pythagorean theorem in this case. So for now, I'll just call this side length X. 13 is the hypotenuse. It's across from the right angle. So we're going to say we have 5 squared plus x squared equals 13 squared, and we can solve this. 5 squared is 25, plus x squared equals 13 squared is 169. Subtract 25, we'll get 144, and the square root of 144 is 12. So FH is a side length of 12. Next, we're going to find our angle measures. And this goes back to just what we did on the last example. We're going to need to use trig in order to do this. So you can choose to find the measure of angle F or the measure of angle G first. It really doesn't matter. I'm going to say let's just use angle F. Let's find angle F. And let's use the side lengths that are given to us. So in this case, side length of 5 and 13. You could use 12, but if 12 is the wrong answer, then you're for sure going to get the measure of angle F wrong. So looking at side length of 5 and 13 in relationship to angle F, 5 is opposite, 13 is the hypotenuse. Opposite hypotenuse is sine. So we're going to say sine of F is equal to 5 over 13. Remember, we need to get sine away from F, so we're going to use our inverse functions. I'm going to take the inverse on both sides, so F is equal to the inverse sine of 5 over 13. You may take your calculators out. So inverse sine 5 divided by 13 gets us approximately 23 degrees, because it wanted nearest degree. So it's approximately 23 degrees. Now for angle G, you could use trigonometry again, or we know that in triangles, all the angles add up to 180 degrees. So in this case, I'm going to go 180 minus 90 minus the other angle we found of 23, gets us an angle measure of 67 degrees.